am I on? Either one. Okay, cool. Well, look, good afternoon, everyone. Lindo, I can't see you, but wherever you are, thank you so much for asking me back to be part of this amazing event. Absolutely enjoying it, and a terrific lineup of faculty. Congratulations for pulling this together. It's just a fantastic thing to be here for. So I'm going to be talking about this hydrogen dive that we did in February this year. And in going ahead with that, though, I just want to quickly acknowledge my good friend and dive buddy, Richard Harris. Now, many of you will know Richard or have heard of him. So he's pretty famous for being the anesthesiologist who anaesthetised the boys in the cave in Thailand prior to that amazing rescue a few years ago. And he is the one who actually did the hydrogen dive. So this story concerns the Pearse Resurgence, an amazing cave in the South Island of New Zealand. So this river, the Pearse River, just flows out of this hole in the ground. Out of that cave you can see right there, and that's me standing in the entrance pool. And looking at that, you would have no idea that underneath there is this incredible cave. So in this diagram, you can see the entrance pool up at the top there. It's linked in through this little passageway we call Nightmare Crescent into this incredibly amazing vertical shaft that goes straight down to about 114 meters. And then the cave just kind of winds its way down, a few little steps here and there. Prior to 2020, we had explored it, or the Wet Mules had explored it to 221 metres. So going back to 2020, we went to the Pearse to try and extend the cave beyond 221 metres, notionally to about 250 metres. And you can see that these are no small expeditions. So that's the logistics on that truck there. One of the problems is that you can't actually drive to the site, so all of that stuff had to be helicoptered in. It is a big undertaking to dive this cave in the way that we're diving it. So a few cold hard facts. In 2020, our plan was to dive to about 250 metres. It was going to be a 16-hour dive, and the water temperature is 6 degrees. That's cold. You cannot spend 16 hours in 6-degree water without some way of preserving heat. So we had to put habitats in the cave. We had 2 deep habitats, so you see there the 40-metre habitat, the 30-metre habitat. They're essentially upside-down water tanks. And then shallower in the cave, we had a 16-metre habitat, that's it there, and then up here you can see this little line going up there, that goes into Nightmare Crescent, and up there we had another one of these habitats, essentially a lift bag with seats in it, up at 6 metres. So that was how we set the cave up from a temperature management point of view. We'd planned the gases so that, this is 2020, at the bottom, at 250 metres, the divers would be using Trimix 491. So 4% oxygen, 91% helium, 5% nitrogen. Now, I get not all of you are techies, so 4% oxygen doesn't sound like a lot, but at 26 atmospheres, that's about the same as breathing 100% oxygen at the surface. So plenty of oxygen. The helium is there because it's light, it's easy to breathe, it's non-narcotic. And then the 5% nitrogen, you might be saying, well, why have 5% nitrogen? Well, that's there for a very specific purpose. It is slightly narcotic, and I'll come back to the reason for including that in just a moment. The problem with that is that it's dense, and I'll come back to that too. So the equipment used was twin Megalodon rebreathers, so 2 completely independent loops with a common DSV that allowed very quick switching between the loops. And so we're still in 2020, and what I want to do here is just show you a very, very brief segment of video that shows what Richard and Craig found at the deepest extent of their dive. So here we are, 242 metres. I'm just going to play this video. This video has sound, so Richard is narrating this.
Now this is exciting. Down to the left there, big hole.
Can we put the volume up a bit, please?
Out of it, and I suspect that is the way on.
So I might just play that again if I can. Can we go back and play that again? Because I don't think you could hear that.
Now this is exciting. Down to the left there, big hole with silt clearly being blown up out of it, and I suspect that is the way on.
Right, so we're at 245 metres, and the way on for further exploration was deeper. And that creates two problems with mutually exclusive solutions. The first of those problems is high pressure neurological syndrome, and I'll come back and explain that in a moment. The second problem is high gas density and the tendency for that to provoke carbon dioxide retention. So when you're breathing a very dense gas that makes the work of breathing harder, and you combine that with even a small amount of exercise, it tends to cause us not to breathe enough to get rid of all the carbon dioxide that we're producing. So carbon dioxide levels in the body increase, and that can cause a variety of different problems. So I'll just go back and explain this high pressure neurological syndrome. So this is a pressure-induced neurological problem that manifests primarily as tremors, which is not particularly useful if you're trying to lay line, trying to operate a rebreather. Ultimately, it can cause cognitive impairment and unconsciousness. There are two ways you can ameliorate or prevent or reduce the high pressure neurological syndrome. One is to go down really slowly, and that's what they do in commercial diving. So to go to 250 metres, they might take hours or even a day. That's not an option for technical divers. The other way you can reduce it is to include a small amount of narcotic gas, like nitrogen, because a small amount of narcosis reduces the high pressure neurological syndrome, and that is why the 5% nitrogen is in the mix. So you might say, okay, you want to go deeper than 250 metres, why not just add more nitrogen? Well, the answer is because more nitrogen makes the gas too dense. So the point here is, and the idea of this concept of mutually exclusive solutions, is you can't fix one of these problems without making the other one worse. So how dense is too dense? Well, we didn't have a good sense of that until relatively recently when Gavin Anthony from Kinetic, a UK testing house for underwater breathing apparatus, produced a database of about 1,000 dives, all conducted in their testing pool at different pressures and different gas densities using rebreathers, where they monitored CO2 levels or carbon dioxide levels in the divers' bodies. This was called end-tidal carbon dioxide. It's basically just a measure of body levels of CO2. And if it rose greater than 8 kilopascals, then that was a dive failure. Now, that won't mean much to you. You're all probably sitting here at the moment with CO2 levels of about 5 kilopascals. 8 kilopascals is a dangerous level underwater. So here's the interesting thing. He found that if you keep the gas density less than 6 grams per litre, that's about air at 40 metres, just out of interest, less than 10% of these dives failed due to high CO2 levels. However, if the gas density got higher than 6 grams per litre, then there was an immediate jump to more than 40 of these dives failing due to high CO2 levels. So there's this inflection in the risk of having high CO2 levels if you let the density get higher than 6 grams per litre. So if we look at what we were using in 2020, Trimix 491, the gas density of that mix at 245 metres, which is where we got to, was 7.3 grams per litre, actually a little bit too high. If you took that mix, even without adding more nitrogen to try and overcome high pressure neurological syndrome, down to 300 metres, it would be 8.7 grams per litre, like way too high. So we've got a problem. The answer would be a gas that's both light and a little bit narcotic. And the question we had was, is hydrogen the answer? Now, we weren't the first people to think of this. A few people have dabbled in it. And a big French commercial company called Comex played with hydrogen actually over a long period, 3 decades. They did experiments in animals, man, they used hydrox, which is oxygen and hydrogen on its own, hydreliox, so oxygen, hydrogen, helium mixtures in dry and wet situations, mostly saturation stuff, not what we're doing, like these deep bounce dives, but some very interesting stuff came out of their program. First, they determined that hydrogen is narcotic, and actually it's a bit too narcotic to use on its own with oxygen below about 160 meters. They determined that it does appear to reduce high-pressure neurological syndrome. It didn't have any obvious adverse biochemical effects, that's good. It did reduce worker breathing because it's light, and it improved work capacity because it's light, so that's good. They did also find, though, that it's very cold to breathe, and that's not so good. However, we determined that if we used hydreliox, 3% oxygen, 67% helium, and 30% hydrogen. Why 30%? Because 30% at 300 meters would be about the same amount of narcosis that they found in Comex produced a anti-high pressure neurological syndrome effect. If we took that to 300 meters, it would be 5.8 grams per litre, so less than that 6 grams per litre threshold. So that was kind of what got us thinking, this could well be the way to go and we need to try it. So, to summarise all of this, the benefits of hydrogen are that it reduces density and it has this anti-high pressure neurological syndrome narcotic effect. And then we have all these concerns. So we know hydrogen's flammable, it can burn, it can even explode. There is pretty good evidence that if you keep the oxygen levels in your mix less than 4%, it won't burn or explode. But we didn't know how to decompress from these dives. We didn't know whether we would be actually getting the narcosis levels exactly right. We were worried about this heat loss issue. We didn't know whether it really would reduce the HPNS adequately, especially given these very rapid descents that we do, and whether it would affect scrubber duration in the rebreather. So there was various worries, but the one that occupied most of our thinking was this issue of flammability and explosivity. And so we needed to try and do some testing on that. I mean, Richard Harris had been talking about this for quite some time, and in fact had already acquired the nickname Hydrogen Harry as a result of this planning around hydrogen. And he was determined that the outcome of this dive was not going to result in him being called Hindenburg Harry. And so he undertook some testing. Apparently, it's not that difficult to get your hands on a cylinder of hydrogen. You just ring BOC and say, I want a cylinder of hydrogen, and they say, what's your address and what's your credit card number? And so he got a cylinder of hydrogen. He had to make it's got a strange thread on the cylinder apparently, had to make an adapter to get our DIN connectors onto it. And then he undertook some testing in his suburban Adelaide swimming pool at his home. The most important criteria for this test was that his wife, Fiona, was out shopping and did not know that this was happening. But basically what he did was he squirted some hydrogen into the loop. He pushed the button to turn on the rebreather so that the solenoid would start adding oxygen, and then he ran for it and hid behind the house. He actually had to go back. He had to go back because the dog had come out and was sniffing the rebreather. He had to grab the dog and take it behind the house and hide. And so nothing happened. And then he breathed on it and nothing happened. So with that comprehensive testing program behind us, we decided that side of it was dealt with. But then what about all these other problems that I listed before? I'm being a little bit flippant when I say this because we did have reasons to believe that most of these wouldn't be a problem, although there was an element of wait and see, but to some extent we dealt with those problems simply by ignoring them. So now here we are, we're fast forwarding February this year, so this is hot off the press. This is probably only the second or third meeting where this has been discussed. We're at the Pearse, ready to do a hydrogen dive. So this is the team, so Richard Harris here and Craig Challen were the two divers who did the deep dive. The rest of us were supporting them. We did a lot of this, sitting around talking, planning, trying to make sure we had a sound way of going about this. took us about 8 days to set up the cave. It's quite a big deal. And this is just a little video of some of the activities that are involved in setting the cave up. So putting the bolts into the wall to anchor the habitats onto, setting the habitats up. This is the 16-metre habitat. Now it's got some gas in it. Putting the footplate on so the divers could get into it easily. The seats aren't in there yet. This is getting one of the deeper habitats through Nightmare Crescent, pretty tight fit. This is it coming out of the Nightmare Crescent into the big vertical shaft, going down where we would anchor it. And once it was anchored, obviously, then we had to put gas inside it to make it float up. And so lots of activity in the process of setting up this cave. The plan was, as I mentioned before, twin Meg rebreathers. So Richard was doing the hydrogen dive. Only one of the rebreathers would have hydrogen in it. The other one would just be trimix. Craig would do a dive with just trimix. So the idea was to dive to 200 metres with trimix. At 200 metres, we'd set it up so that he would have about 3% oxygen in the loop, so something that should be safe. Introduce hydrogen by exhaling into the water, a switch block, and then inhaling through the hydrogen through the ADV to top the loop volume up. So introducing hydrogen at 200 metres, proceed to 230 metres, spend some time there, get a sense of what it was like, then come back to 200 metres. Then we had a flushing process that would finish at 150 metres by having all the hydrogen gone from the loop, and then increase the PO2 set point for the decompression. That would bring the oxygen percentage up substantially, but it should be safe at that point. Lots of planning. This is what I would call iterative choreography. In fact, this is just one of many written plans. It just happens to be one I took a photo of. You can see there's another one on the other side of that piece of paper, but depths, times, signals, who's going to visit, what we're going to take down, what gases are going to be using, all this kind of stuff. Lots of planning went into this. So the day of the dive, this is Richard and Craig getting into their gear. This is them leaving the surface, so Harry in the lead, Craig just behind. That's Nightmare Crescent. You can see that black hole that Harry's illuminating up there in the corner. And then there's no actual video of the dive. However, I did quite a bit of underwater videography with these guys during their Workup dives, and I got this video I'm about to show you on a Workup dive to 180 metres. So this is exactly what it would have looked like on the day itself. So you'll see here that not actually that, but here, this is what it would have looked like. So this is Craig coming out of Nightmare Crescent, so we're at 15 metres here, and now coming into the main shaft. The next little segment you'll see going down the main shaft, that's I think the 40-metre habitat there. This is coming through the needle bender at 120 metres, and this is Craig going past. As Harry goes past, if you have a look just on top of the left-hand sling tank, you'll see the hydrogen cylinder sitting there. So here he comes into view, and there it is. That's the hydrogen cylinder, that little cylinder there. So this is going down into a place called the Big Room. I followed them down, so this is about 130 metres now. I followed them down into what's called Brooklyn Exit. At about 150 metres, I turned back. And look, honestly, it taught me, a lot of respect for diving in these cold water caves. I did this dive I had about 4.5 hours of decompression in 6-degree water, really cold, and I didn't use the habitats. It's very challenging diving in these kind of conditions. So this is us waiting for them to resurface. Started it early in the morning, finished in the evening. So Harry being interviewed by the documentary crew. It all went pretty smoothly. A few little hiccups, but not too many. So what can we take out of this? Well, the first thing to say is that it's the N of one, right? We've done one hydrogen dive, and one has to be careful what one concludes on the basis of one thing. However, back calculation from the tank pressures and the loop volume suggested we had about 35% hydrogen in the mix at 230 metres. Harry found it easy to breathe, he wasn't cold, it was very short exposure, so we haven't solved that problem necessarily. No lung symptoms. Here's the most fascinating thing though. Harry had tremors at 180 metres when he was on trimix. He gets HPNS quite badly. They had gone by 230 metres when he was on hydrogen. So appeared to do, N of 1, it appeared to do what it was supposed to do. So what conclusions can we draw from this dive? Well, the first conclusion, and probably the only one that we can draw with 100% certainty, was provided for us by my colleague David Dulett, and that is that the probability of survival in such a dive is greater than 0. We definitely can say that, but probably not a lot more. The other thing I think, though, but to be fair to us, it may well be that the history of technical diving reflects upon this dive and says, well, okay, this was the day that the gateway to exploration beyond 250 metres with gas of an appropriate density was the day that the door opened for that kind of exploration. And I mean, you know, we'll see. Time will tell on that. And that's actually technically the end of the presentation, but I have one little short video to show you that Arlindo asked me to put in there because it's not officially part of my talk. Now, we were worried about this explosivity thing, and because we're boys and because we're in a remote location and kind of wanted to see if we could blow something up, we decided to see just how explosive hydrogen really is. There's an element of stupidity about this, so this is why I'm not putting it as sort of an official part of the presentation. So anyway, the video will tell the story. Just make sure the sound is up, guys.
It's not very buoyant. Well, we're starting like the dive. Yeah, I hope you can tie the net first. Whoa! Yes! Fucking hell! Wow. Lucky we started small.
Okay. So, you do have to worry about it.